Hello, in this video today we're going to revisit looking at Gemfiner's supercomputer. It is an electro-ballmatic machine. That means it's partially electronic and it's also partially ran by ball bearings running around everywhere. And it's basically Conway's game of life. It's a generative marble computer thing. We've already done a video on this where I went to pick up its dismantled carcass from EMF Festival and figuring out what the fudge it is. We chatted to Gemfiner about what it was in that video, so the link is below if you haven't watched it already. This all may make a lot more sense if you watch that video first. By the end of the video you will see it is absolutely massive when it was all put together, and remember this was, even in that form, a cut down version of the original supercomputer that was inside a shipping container. At the bottom these xylophones represent cells. Living cells, and they live and die like in Conway's game of life. This is a single row of 5-bit cellular automata. At the start you choose a couple of cells you want to be alive, that one and that one. These two cells designate to their own marble droppers at the top of the machine. Those marble droppers then drop marbles into the back of these things. These are free input AND gates. These ball bearings then fall into the back of designated flaps on these AND gates. This creates a new state where we can figure out which cells are going to die and which ones are going to come to life again at the bottom in the next phase of the calculation. Then there is another ball dropper at the top. These fall down and go through the gates and test the states that the gates are in. If all of these gates are 0, the ball will literally go all the way over to the end, travel down and go into one of the cells, causing that cell to come to life. However, if one of these gates is 0, the ball will fall down that and then go into the waste gate and just be ignored by the whole calculation. With this rather convoluted sequence of marbles, you will end up with different cells at the bottom alive and different cells dead. At the start it had 5 and 3. After this one, let's say, you may end up with 5 and 3 dying and 4 and 2 coming to life. If you keep on repeating this, the cells will keep on coming alive and dying in a sequence that can be extrapolated to use for different things. In the last video, we used these 5 cells as 5 bits of data. We converted this 5 bits of data into letters, which then ended up spelling a word. And I imagine if you go for long enough generating a sequence, you may end up with a funky sentence in Klingon for all we know. In order to start the whole thing, you need to have some sort of idea of what the output is. I'm going to drop one in number 5. That's going to ding and it's going to roll down. And now it lands on this. There's actually a switch down there, so it notices it's landed. So let's put... Now those 3 lights are on because those 3 marbles are pushing down switches. So this is the output. So there's 5 bits, 1, 2, 3, 4, 5, and we've got 0, 1, 1, 0, 1. So now that's going to be fed back into itself to drop marbles into the gate. These gates should receive marbles on them. Have a look and see if you can notice any marbles landing in these separate gates. Okie dokie. Test number 1. Most of them will go straight to the output because all of the rules won't be met, but there must be at least one that's gonna... There was one, then we've got the next output, 11101. The issue with that video is the machine never properly worked. It was just too massive. Balls got stuck everywhere. We had that problem at the end of the last video. So we came to the conclusion a month or so ago that the only way we were going to get this to work was to somewhat shrink it in size. So the first thing I did was mostly take it to pieces. This actually took quite a while. As you can see, there is a lot of it. But it did double up as a pretty comfortable futon. I then cut the Dexian frame I built pretty much in half, so it was half the size. And also built a platform on wheels so we don't have to dismantle it again. It could just stay on there and could be wheeled to its destination. So I made 2 rolls of the ball droppers, 4 at the back and 2 at the front, which meant the pipes could be shorter and a better chance for the balls to get to their destination. I put all of the existing electronics from the last video on a board at the back of the machine, and also added solenoids so we could remotely drop the marbles back out of the gates and out of the cells at the bottom. One of the biggest problems I found were the hoses kept on falling out the back of the rules, so I made these flanges so they would stay a little bit more snugly in there, which meant the balls could just travel freely to there without getting stuck even more. The 5-bit glockenspiel cell thingamajiggy now lives directly underneath the cells, and after a bit more wiring, Gem offered to come and spend the day putting the hoses in.
So we're just going to 1, 2, 3 like that.
Looks good.
Yeah.
Well, oh, one come out of there.
One came out of there, but one...
Where did one go in the...
Oh, yeah. Ah, it's not far enough. It's
Sorry?
not in the whole way.
Because Jem knew more than me about where all of the hoses go, he spent about 12 hours cutting and putting all of the hoses in place and making sure they all work, whilst I was wiring all of the electronics. All of the wires that were in the previous video all still needed to go to all of the motors that lifted the marbles and also agitated the marbles at the top, and also all of the wiring to the cells.
Yeah, all the cells are wired into the backs of the computational units. Now we have to wire in the tester circuit into the sides of these.
We forgot to check what gates we're going. Lovely. That was good. It was a very long day, so there wasn't much time to test it all at the end. But in the morning after, I put all the marble waste lifters that brought all the marbles from the bottom back up to the top. We've got it partially working again. We can move to the next step, which is trying to make this talk to a modular synthesizer to hopefully make some music. How are we going to do that, you ask? Well, we need to take the digital data, I know, digital from balls, these 5 bits of information, and convert them into a useful voltage for the modular synthesizer to be able to use. Because modular synthesizers use control voltage. The higher the voltage, if you plug it into an oscillator, the higher the note will be. So we need to figure out a way of converting this into an analog voltage to be able to talk to the modular synthesizer. So imagine the switches that the balls sit on at the back of these cell xylophone thingamajiggies. Imagine they are 1s and 0s. We've got a 5-bit long value of 1s and 0s. If you write out all the combinations of these 1s and 0s, you'll end up with 32 different combinations of 1 0 0 0 0 1 0 0 0 1 blah de blah, which means from these 5 bits we can get 32 different values of information. If we plug these 5 bits into a digital to analog converter chip, in this instance a DAC 0800, this is the data sheet, then we can convert these into an analog voltage. So I put a DAC 0800 onto a breadboard and kept on fiddling around until it started working. There's the full version of that on Patreon if you're interested. There's a lot of going, why isn't it working? But then it's figured out and explains how it goes. I ended up using an example circuit in the data sheet and it did what I needed it to do. What it does is it takes all the 1s and 0s, 1 being there's a ball on it, 0 being there's no ball in it, and converting that to a voltage between 0 and 5 volts. In this bit, you can see me flicking switches that are pretending to be the switches behind here. As you can tell, when I'm changing the combinations, the oscillator pitch, which is wired into the voltage coming out, is going higher and lower depending on which voltage is coming out of this. To the point that if you know how to count in binary, you can go up semitone by semitone by just flicking the switches that designate to the bit number. Next note is this. Next note's this. Next note is this. Next note is this. Next note's this. Next note is this. Next note is this. Next note is this. Now we know it's working, we can plug it in between the supercomputer and the modular synthesizer. But first we need to patch in the inputs of the supercomputer so we can actually sequence the events of the supercomputer with the modular synthesizer. This includes things like trigger in to drop the balls and also triggers to delete the balls from all of the AND gates. Now we plug more jack cables into the input of the digital to analog converter and wire those into the output of the different cells on the supercomputer. Also, because we want to take as much information as possible from the supercomputer to make sounds with the modular synthesizer, I soldered these contact microphones to jack sockets. We're going to use these Cosmos safety valve modules to amplify the signal from the contact mics into the modular synthesizer. And then we're going to hot glue them onto bits of the supercomputer. But anyway, let's patch in the modular synthesizer and make some sounds. We've got it plugged into this module here, which talks to this BeatStep Pro. So when I hit notes on this BeatStep Pro, you'll see that this lights up over here. You'll figure out why it's plugged into the BeatStep Pro in a second, but first, let's get this whole thing doing what it's supposed to be doing and starting to do calculations. So first we'll get the ball rolling by putting in our first kind of starter state. We're going to go for bit 3. Bit 1, I think that's bit 1, or is it bit 5? And this one up here as well, screw it. Let's go busy. The next thing we're going to do is we're going to click on the learn button over here, which is going to update the digital to analog converter. Those are the marbles that we put in. Now we're going to push the sell button, which is going to drop the programming marbles into the AND gates. Whee! Some of them fell out, but that's just gonna happen because it's bloody marbles. Now we're gonna clear the marbles from the test gate. We should hear the sound because there's a contact microphone on it. Now we're gonna drop the test balls, which are gonna travel through the AND gates and down and give us the next states over on here. Let's push it over. Now we have a new state, we need to update the DAC, which is going to change the note on the modular synthesizer. So let's update the DAC. There's a higher note. Now we clear the cells. All of those marbles go up to the runner and back into the skippers at the top again. We could potentially program a sequence with the BeatStep Pro, which is a sequencer, and this could all run autonomously. And that's what we're going to do right now. Right, I'm going to program clearing cell for that long. Drop the cell. Now we're going to clear the test. Now we're going to drop the test. Which will be a new test all entirely. And then we're going to learn, which will update the note on the modular synthesizer. Completely different note. Right, I'm just going to press play and see how quick we can make this do its thing. Oh! Jesus Christ almighty. Oh, there goes the test cells. I'm going too quick. Anyway, that's it for this video. This setup is far from perfect. It still needs quite a lot of fine tuning. I've got big plans of making specific synthesizer modules, of making the most of what is going on around here to make complex melodies. But whether or not that happens sooner or later, who knows? If you want to support these projects and also the museum that these projects end up in, then go and check out it over on Patreon. The support really helps it tick along. There's also multiple detailed videos as I was doing it of making these and the problems and the solutions along the way, as well as an edited version of the song from the supercomputer in this video, and samples that you can download and use from this setup. Oh, and also the hour-long video on breadboarding the digital to analog converter circuit. Needless to say, there's a load of other stuff. The link is below. Anyway, I'm Look Mum No Computer. That's it from me and the supercomputer. Oh no, I'm talking about computers. Oh, anyway, don't be scared to try it.